We're going to talk about Markov chains. And Markov chains are a way of following some kind of a trend. We're going to be looking at business trends, but you can also look at different trends in society. In this first example, we're given an advertising campaign. So Dutch Brothers has 35% of the Wenatchee drive-through coffee market, and other companies have 65%. Suppose Dutch Brothers starts a big advertising campaign, and when they do, their results are represented by this transition matrix. So this transition matrix, so let me write that language down, transition matrix, tells us what's going to happen to the customers. So let me describe, for example, the number in position row 1, column 1. That would be this 0.8. So the number is 0.8, and or 80%. That tells me that of the customer that went to Dutch Brothers the last time, the next time they go, they're going to go to Dutch Brothers again. The 0.2 here, so that would be in position row 1, column 2. So that 0.2 tells me the customer that went to Dutch Brothers last time, on their next visit is going to go somewhere else. So 20% of those are going to go somewhere else. Position, let's go to the other column. So position, let's see, that would be row 2, column 1 is 0.45. So this number says of the customers that went somewhere else to get their coffee last time, 45% are going to switch to Dutch Brothers. And then finally, 2.2, customers that went somewhere else last time, 55% of those customers are again going to go somewhere else. Okay, so this is the transition matrix. Some properties of the matrix. You'll notice in this matrix, as we look at the rows, each row, so row 1 adds up to 1. 0.8 plus 2 is equal to 1. Same with row 2. 0.45 plus 0.55 is also equal to 1. So each row, this is not true of the columns, each row adds up to 1. Another property is that every single entry, the 0.8, 0.2, the 4.5, and the 5.5, are all between 0 and 1. You'll see zeros in these matrices, you'll see ones in the matrices, but nothing bigger than 1, and never a negative number. And that's how you can tell that you've got a matrix. So for example, if I gave you 0.7, 0.5, and then, I don't know, 0 and 1, the second row is fine, 0 plus 1 is 1, but the first row, 0.7 plus 0.5 is 1.2, so this cannot represent a transition matrix. Next, we're going to draw the transition diagram. The transition diagram is a great way of describing what I was describing up here verbally. It's actually a little easier to see that with this diagram. For the transition diagram, each of our categories, Dutch Brothers and other, gets a circle, but it's not a Venn diagram circle. It's just a way of representing our two groups. So Dutch Brothers and other. We're going to start with our Dutch Brothers group. If a customer went to Dutch Brothers last time, 0.8 of those, or 80% of those, are going to go to Dutch Brothers next time. So I'm just going to loop those back to Dutch Brothers and put a 0.8 to represent that. Of the people that went to Dutch Brothers last time, there's lots of people who do this. They just go to whichever one's convenient, right? So this isn't necessarily bad. Of the people that went to Dutch Brothers last time, 0.2 are going to go somewhere else next time, whether because of convenience or whatever other reason. Our other group, 0.45 are going to go to Dutch Brothers next. So if we started other, 0.45 of those are going to go to Dutch Brothers next. And again, of the other group, the other 0.55 or 55%, if they started in the other group, they're going to go right back to something other than Dutch Brothers to get their coffee the next time, 0.55. We call this a transition diagram. We'll see some other transition diagrams here in a minute once we finish with this example. So that's the transition diagram for this one. We want to find the market share after one campaign. We've got a market share right now that we were given. That's the 35% and the 65%. That was the current market share, and we can express that as a probability vector. When we put our probability vector together, we want to express that in the same order that we did in the matrix. Dutch brother comes first, other comes second. This is a vector. Really, it's a row matrix. I don't know if that helps you anymore, but it's a row matrix. So it's a row matrix, Dutch brothers first, and then other comes next. So this is Dutch brothers, and that's other. This is our probability vector. Really, it's our market share for this example. We want to find the market share after one campaign. To do that, we're going to take the initial market share, 0.35, 0.65, and we're going to multiply it by our transition matrix. The transition matrix is how those customers move from one group to another after the advertising campaign. I am not going to multiply this by hand. I'm going to put this into my calculator, and we'll do that for all of these. We're not going to be multiplying any of these by hand. So I want to be able to put the probability vector in first, that row matrix. I'm going to go to my matrix, which is second of x to the negative 1. I want to do, this is one row, two columns. So I want to do a 1 by 2 matrix. Let's change matrix A into that. It doesn't really matter which one you pick. We're going to go to edit to do that. Edit, enter, and I want 1 by 2. And remember, on these you can't mess up. I'm going to actually go backwards here. If you did 2 by 1, it would look wrong. So it's really pretty straightforward. Okay, we want 1 by 2. And the numbers going in for the current market share are 0.35 and 0.65. Now I need the transition matrix. So I'm going to quit here. I'm going to go back to matrix, second x to the negative 1, over to edit, and I'm going to choose matrix B now. It's already 2 by 2, so I've got the right dimensions. I want 0.8, 0.2, 0.45, 0.55, and I've got my transition matrix. Remember, I called this one A, and I called this one B. So I want to do A times B on my home screen. Okay, so second quit. I need to grab matrix A, so second matrix. I'm going to choose A from my names list, enter, and then times B. So I think you can leave the times off. I'm going to put it in though. Second matrix, and then choose B, and then enter. So we end up with this market share. We get 0.5725, 0.4275. If I write that down in percentages, we now have 57.25% Dutch brothers and 42.75% other. Okay, there's Dutch brothers after the advertising campaign. There is Dutch brothers before the advertising campaign. So I would say, you know, whether this was coupons or whatever, they got a lot of customers to come to Dutch brothers. 57% is a really significant increase. Let's see if we can increase it even more. Let's find the share after 3 similar campaigns. So this would be after 1. If we wanted after 3, we'd have to multiply 3 matrices times that 0.35. So 0.35, 0.65. Rather than writing 3 matrices here, I'm going to write 0.8, 0.2, 0.45, 0.55. I'm going to take my transition matrix and raise it to the third power. Okay, so what does that really look like? Matrix A times matrix B to the third power. Okay, so 3 applications of this. So I want to grab matrix A, so second matrix A times second matrix B, and I want B to the third power. Okay, again, we get another pretty significant increase, and that is 0.6776, 0.32. I can't see it all, but it says I can use the right arrow to see it. Let's call that 3224 if I round. So 67.76% Dutch Brothers, and then 32.24% other. Okay, so whatever advertising campaign we've got going on here, we're getting a lot of customers to either switch to Dutch Brothers or to come back to Dutch Brothers. Pretty effective campaign. What is the transition matrix for 3 campaigns? This is our probability matrix, or the initial market share for this example. So the actual transition matrix we're using is this for 3 campaigns. If I wanted to find the transition matrix for 3 campaigns and know what those entries are, I would use B to the third. So I want to know what just B to the third is. I'm going to put that into my calculator. Matrix B to the, using that caret key, third power. So we get, let's do 2 decimal places. That's kind of a pain. Maybe 3, 0.706. 0.6626 would be 3. And if I arrow over, I get point, can you see what I've got there? Let me move that down a little bit. 0.295 if I round. And then 0.337. As you're doing these, it's a lot of work to round these. You've got 4 values and to move everything over. So I want to show you just one more trick. Certainly you can do it this way, but there is a rounding feature on your calculator. It's in the math menu. So if you go to math, you arrow over to number. You have the rounding option, which is number 2. So number 2. I want to round what I just did, and that was B to the third. I'm going to put it in again. Second matrix B to the third power, to the third power. I'm going to arrow over, so I'm at the regular cursor, comma above the 7, and I want to round it. What I do, 3 decimal places, comma 3, parentheses. Isn't that nice? So then it rounded everything for me. I didn't have to arrow over. It's a really nice way to see those big values that show up in your matrix. Okay, so we talked about some important vocabulary terms, some important concepts that go into the Markov chains. Where's the chain part, right? Well, the chain is really, this is a good example of it. I've got my initial market share, and I'm chaining on these applications of the marketing campaign. So that's what we mean by a Markov chain. I didn't actually talk about that piece. We've also talked about the probability vector. So that probability vector is that initial market share vector. It's always a row matrix. We also talked about the transition matrix, and that was that 2x2 matrix that we used to compute the market share results. And then the last vocabulary term was this transition diagram, and that got us from visually from the initial starting place for a customer to what they did the second time around. I've got another example, another transition matrix. I wanted to make sure we had a second one of those to look at. This one talks about income classes. So this is a social science application of the Markov chains. Okay, so we've got income classes from one generation to the next. So we've got this current generation, and I used L for the lower class, M for the middle class, U for the upper class. And this is by income. I didn't write down what the incomes represented, but lower, middle, and upper. And what this one tells me, so I'm going to look at this one. Oh, and these got cut off, didn't they? Lower, middle, and upper. So this tells me that if the parent is in the lower class, the child is 65% likely to stay in the lower class. The child is 28% likely to change to the middle class, and 7% likely, so that's my probability, to move to the upper class. So is the above a transition matrix? Well, I can do a quick check here by adding those rows up, 0.65 plus 0.28 plus 0.07. That adds to 1, 0.15 plus 0.67 plus 0.18. The next row adds to 1, third row, 0.12 plus 0.36 plus 0.52. Also adds to 1. So each of my rows, the columns don't matter, each of my rows add to 1. All of the values in my matrix are between 0 and 1. I happen to not have a 0 or a 1, but I could. I don't have any negatives and no values larger than 1. So is it a transition matrix? Yes. Okay, here comes the transition diagram. So we have our lower class, our middle class, and our upper class. This is generation number 1. This is the next generation. So you can think of this as the parent and the child. So if the parent is lower class, they are 65% or 0.65 likely to stay in the lower class. So I'm just reading this first row now. 28% of them will move to the middle class, 0.28, which you can also read as a probability. 0.07 would move to an upper class, 0.07. Okay, next is the middle class. I've got some different colors. Why don't I do that so you can really see what these are? So for the middle class, I'll do that one in yellow. For the middle class, there's a 15% chance that they'll move to the lower class, 0.15. Middle class, I'm doing this row now, 0.67. 0.67 that the parent, and then the next generation stays in the middle class is 0.67. And then from the middle class to the upper class, 18% chance, so 0.18. I'm going to use my pencil for this last group for the upper class. Okay, for the upper class, there's a 12% chance that they will move to the lower class, so that would be 0.12. A 0.36 chance that they'll move to the middle class, 0.36. And a 0.52% chance that they will stay, that child will stay in the upper class. Okay, so actually I did pretty good. That's pretty neat. So there's my transition diagram. What does the entry in the second row, that's my middle class row, and third column mean? Okay, so that would be that 0.18. So I'm looking at that 0.18. So we would read this as, we could read this as a probability, or we could read this as a straight percentage. I'm going to read it though as a probability. So there's an 18% chance that a child with, so the child, right, is the next generation, with a middle class parent will become upper class. And I'll say we'll move to the upper class. Okay, in the initial generation for the study, we've got the distribution of those classes. We want to know what the probability vector is. Again, you want to make sure that you're in the same order. So you're going to do lower, middle, upper. Probability vector is that row vector. We are given lower first, so I'm going to express those as decimals. So I've got 0.21, and then 0.68, and then 0.11. So that's my probability vector. Finally, what is the proportion in each class after 2 generations? If we were to figure it out after 1 generation, that would be the probability vector, 68.11 once. Okay, I'm going to just write this down once. 0.28, 0.07, 0.15, 0.67, 0.18. We're going to transfer this into the calculator real quick. 36.52. That would be after 1 generation, but if I want to know what it is after 2 generations, I'm going to do power of 2. And when I move to 4 generations, I'm going to go to power 4. So to answer that first question, let's call this A and call this B. We're going to take matrix A, after we type it in there, times matrix B, 2, we want 2 generations to the second. Okay, so very carefully, let's get our matrices typed in here. Turning my calculator on, I'm going to go to the matrix menu, and I want to edit. So I'm going to go over to edit, and I chose A. It was a 1 by 2. I'm going to make this a 1 by 3. And I type in my probabilities, 0.11. So there's matrix A. And I go back to the matrix, and I'm actually going to go up to my original one to make sure I didn't make a mistake. And I'm going to go to matrix B, but I want to edit that. So matrix B, this is a 3 by 3. So I did 3, enter 3. And I'm going to very carefully type in my probabilities, 0.07, 0.15, 0.67, 0.18, 0.12, 0.36, 0.52. I'm going to review these before I change screens here. So easy to make a mistake. Okay, and they look good. So now I'm ready to let the calculator do the rest of the work. I want to know after 2 generations. So quit. I need matrix A. So second matrix, I'm in names now. I want A times matrix B. So second matrix, I'm going to choose B, but I want 2 generations, so I want caret, or you can pick the squared key, caret 2. And you know what? Let's do round again. It's really hard to see these values. Let's do that round 3. This is a really great time to do that. So to do that again, I'm going to go to my math menu, over to num. I'm going to choose round. And I'm going to do this operation again. So your calculator may or may not let you arrow up. If it doesn't let you arrow up, you can do second enter, and it will bring up your calculations. So I can arrow up and grab that calculation, and then comma is above the 7, and then we said 3 decimal places, so 3. Okay, really, really nice. I'm glad we did that. So that gives me 0.27, 0.27, 0.512, 0.218. Okay, so take a look at what's happening. The middle class is pretty close to the same, 21% and 27%. Not the middle. This was lower, lower, middle, upper, right? So lower, middle, upper. Okay, so the lower class has increased just a little bit. The middle class has gone down, gosh, almost 17%, so by quite a bit. But look at that upper class. The upper class is almost doubled. Isn't that interesting? So the upper class has really increased. Let's do now 4 generations. Okay, I am not going to type all that in again. I'm going to go back and I'm going to choose this one. If you can't arrow up and choose it, do second enter. And there it is. I want 4 instead. 4 instead. Look how quick is that. Okay, so after 4, so this is A times, this is 2, B to the 4th. Remember, we haven't changed those matrices at all because we didn't use that store feature. This gives us 0.282. Lower class is pretty close, not a huge change there. 0.492. Didn't change a ton, really kind of steady there. And then 0.226. Let's see if we can get this to change significantly. So if we go up again, I know this wasn't on there, but let's go 6 generations out. I've got 28 still, really close to 49%, really close to 22%. Do you see how it's starting to settle out? Let's do, I don't know, let's just go for broke. Let's do 10 generations. After 10 generations, this is really steadying out. So after 10 generations, we get 20.286, 0.489, and 0.225. So if our trend continues, that means that the proportion of classes starts to stabilize. And the trend doesn't necessarily continue, but in this case, if it does, we start to stabilize the proportion in each classes. It's really interesting to see how those trends can start to lead to more of a fixed proportion.